BTEC Applied Science, Unit 16, Astronomy, and this is about assignment B. Now, it's a big assignment, there's a lot to it. I was thinking I might make several videos, changed my mind, I made one big video about assignment B. So, 4 sections. First section is about telescopes. I'll give you more detail about each section on a separate slide, but just as a summary, section 1 is about telescopes, different types of telescope and how they work. Some important telescopes, such as the Hubble telescope, and also some practical work that you have to do, measuring the focal lengths of lenses and mirrors and things. So section 1 is telescopes. Section 2, nighttime observations. You have to do some observations, some of which using a telescope. A series of nighttime observations. You should learn and explain right ascension and declination, altitude and azimuth. We'll see. Section 3, daytime observations. Again, a series of daytime observations. And then section 4, a big section. If you want a distinction, you do good evaluations of all your measurements and observations. So section 1 is about telescopes. You must do some practical work and have evidence of this practical work. Measuring the focal length of some lenses, convex and concave, measuring where the focal point of parabolic mirrors are. You should explain why the mirrors in reflecting telescopes should be parabolic and not spherical. With my group, we make simple telescopes with just a couple of lenses, and we measure the magnification and also the field of view. You should explain what these things mean, by the way. Then we want a report on reflecting and refracting telescopes, simple ray diagrams for each and some explanation as to how they work, what the advantages and disadvantages of these two telescopes are. You should explain things like magnification and how you work it out, field of view, chromatic aberration and spherical aberration. Then a report on at least 5 important land-based telescopes and 5 important space-based telescopes. For example, the Hubble telescope. What parts of the EM spectrum do they observe in? What is their job? Who sent them up? Was it NASA or the ECA or somebody else? And what important discoveries and things have they made since they've been up there? Nighttime observations. Now, there are several things that you could do. I mean, look at the specification. It doesn't specify too much here. This is what I ask my students to do. I ask them to sketch several constellations. I ask them to do several detailed sketches of the moon using a telescope or binoculars. And I ask them to track the position of the moon over a period of time. At the same time, over a week. Track the position of the moon in the sky. Okay. Sketching constellations, I'm not going to go into too much detail, but you estimate the magnitude of the brightest stars by comparing them with stars in Ursa Major. What do I mean by the magnitude of stars? Well, it's how astronomers measure brightness. They talk about the apparent magnitude of a star. You should be taught that, or look it up. Several detailed sketches of the moon. Track the position of the moon. Now, when I say that, I want to know its right ascension and declination over a period of time. For example, the same time every night for a week, and you plot those on a star chart. I strongly suggest you get this app on your mobile phone called Stellarium. Stellarium's a brilliant program on my desktop and on my phone app, and you can basically point it at something and it will tell you its right ascension and declination. So Stellarium I recommend, and it's free, which is good. All of the observations that you do should include the time and the date, the location, what the seeing conditions were like, and what equipment you used as well, what telescope, what binoculars you used. Along with those nighttime observations, you should talk a little bit about what these numbers actually mean. What is the celestial sphere? What are right ascension and declination? It's something that astronomers use to show the position of a star on the celestial sphere. Well, could you explain that? Find it out, explain it. Or you should be taught it, actually. Your teacher should tell you. The magnitude scale, basically the brightest star apparently is a 1, apart from the sun, and then the dimmest star in the sky is a 6. How do astronomers use this magnitude scale? Explain that the apparent magnitude of a star depends on its luminosity, how much light it gives off, and how far away it is. There's actually an equation for working out the distance you might want to mention. What is the ecliptic? Very important. What is the ecliptic? And explain the apparent motion of the moon. I will tell you that the moon is always close to the ecliptic. Explain the appearance of the moon, as in you've already explained the phases of the moon. You could refer back to that in assignment A. And then what named features on the moon did you observe? Did you see any craters that you know the name of, such as Tycho, Copernicus? Did you see the Sea of Tranquility, the Sea of Crises? These are named features on the moon which you may or may not have observed. Daytime observations, and again, this is what I ask my students to do. There may be some variation in what you are asked to do. We observe sunspots on the sun using something called a solar scope, which is brilliant. It's very, very easy to use, and if there are sunspots on the sun, you can see them. There are other ways you can look at the sun. There are projection methods. We also look at the sun using pictures from the SOHO, the Solar Helioscopic Observatory, and it has a fantastic website, and we compare what we see with what we see with the solar scope. Tracking the position of the sun in the sky, and you do that using a shadow stick. So you put a stick in the ground, you measure the direction, the length of the shadow, a bit of trigonometry, and you can work out the altitude and the azimuth of the sun. What does that mean? Well, you're going to explain it. Then we make our own sundials out of cardboard. We make equatorial sundials. Then we tell the time on the same day at different times in the day. We tell the time using our sundial, using a proper posh sundial, and also comparing it with GMT. So using a sundial. Again, there are lots of explanations that go with the daytime observations. Talk about why is it dangerous to observe the sun? How can one observe the sun safely? Different ways of doing it. Why does the appearance of the sun change over time? And that's to do with its rotation. The sun is rotating, and also the sunspot cycle, which you should have talked about in assignment A, the sunspot cycle. Why does the position of the sun in the sky change as it does throughout the day? This is talking about when you're tracking the sun. How does the path of the sun change in the summer and the winter, and why? How and why does it change? How do sundials work? How should you set up a sundial correctly? You know, the gnomon is pointing towards Polaris. So it's at your latitude. You should mention the equation of time. I've actually done a video on sundials, which is on this channel. See if you can find it. Watch it. Then the fourth section, section 4, evaluating your observations. Basically, compare your observations with published material. For example, your sketches of the moon, look at photographs of the moon and what can you see on your sketch which you can see on the photograph? What can't you see on your sketch? Compare them. You might want to talk about something called the shadow terminator. Look it up. How do your sun observations compare with the photographs taken by Soho? Your constellation sketches, how are they different to, if you look on Wikipedia and you type in the name of a constellation, you'll get a little star chart of that constellation, and it will tell you the magnitudes of the most, well, a lot of the stars in the constellation. You can compare your magnitudes with those. Obviously comparing your sundial times with GMT. How good is your sundial? How accurate is it? And then the position of your sun, your alt and as of the sun, compared with, there's an excellent website called suncalc.org, and that will tell you at your location on a particular date the altitude and azimuth of the sun. It's very, very good. Okay, so for all of your observations, comment on the accuracy of the observations, suggest why errors occurred. For example, light pollution, that would affect how many stars you can see. Not letting your eyes get used to the dark, so night vision. A couple of examples, there's lots more. How you might have achieved more accurate results. Perhaps a different location, perhaps done it at a different time of the night or a different time of year. How many observations you took, what equipment you used, any other aspects of your method which would have affected the accuracy of your observations, how might you have improved them? And that's Unit B. It's a big unit. I think it's the biggest one, and it involves getting out there and actually doing some observations. You must do.